In this example, we're going to estimate the sample size needed to estimate a population mean and be within a certain margin of error. So in this problem, we're asked to estimate the mean amount of time that full-time college students spend watching TV each weekday. So we don't know what mu is. We're going to try and estimate it, and we're going to estimate it with a 96% confidence interval, okay? We want to make sure that our margin of error, so our margin of error is no greater than 15 minutes. I want you to keep in mind that the margin of error here, notice that the unit is in minutes, and that's because the unit for the mean is also in minutes. So you want to make sure that your margin of error, the units, match up with the unit for your population parameter. Okay, so I'm going to start by writing down everything that I have. Also, another important piece of information, which I didn't read out loud here, is that we're assuming that we know the standard deviation to be about 112.2 minutes. So this is sigma. Oops, let me use a pen, not a highlighter. So sigma is 112.2 minutes. Okay, I'm going to write down all the information that I'm given using the correct notation. So here, let's see, what do we have? We have sigma. I'll just write that down again. We know our margin of error is 15 minutes. And we want to build a 96% confidence interval. So that tells us that our confidence level is 0.96. So our alpha or significance level is 1 minus 0.96, which is 0.04. And I'm going to go ahead and calculate alpha divided by 2 because you'll need that to compute the critical value. So that's 0.04 divided by 2 or 0.02. Okay, let's go ahead and create let's go ahead and find the critical value. So remember that the critical value, let me make a sketch of what the critical value is. The critical value is the z-score, so that's z sub alpha divided by 2. That separates the right tail region, so this shaded region here, that's alpha divided by 2 or 0.02. So the area of that shaded region is 0.02. And it's the score, so it's the z-score that separates that region, the red region, from, I'll say, the green region, from everything to the left. Okay, so this green region here on the left, that is, let me find an appropriate color here. Okay, so this is 1 minus 0.02. So you need that information to find the critical value if you're using your calculator. So I'm going to use my calculator here to calculate that critical value. So z sub 0.02 is inverse norm. So use inverse norm to find the z-score. Type in the area to the left of that z-score. So the area to the left is 1 minus 0.02. And then we always use 0 for mu and 1 for sigma because we're on the standard normal distribution. And that gives us a critical value of 2.054. So that this value right here is 2.054. Okay, now that I have all the information, all the pieces, I can use the formula, this formula here. So you just have to memorize this formula. There's no button on your calculator that will calculate the sample size for you. So once we put everything in, we'll be able to estimate n. So n is going to be greater than or equal to our critical value, which is 2.054, times sigma, which is 112.2. Divide that whole thing by your margin of error, which is 15, and then raise this whole thing to the second power. So type all of that into your calculator, and you should get something close to 236.05. So let's go ahead and just round that to 237. So this tells us that we need a sample of at least 237 in order to assure a margin of error no larger than 15 minutes. So if I want to estimate, right, the mean amount of time that full-time college students spend watching TV, I need to survey at least 237 college students and ask them, hey, on average, how much time do you spend watching TV, so that I can estimate mu at a 96% confidence level.